Hello, this is Tucker from the Math and Physics Resource Center at SCSU, and in this video we're going to go over compounding interest. So compounding interest has a nice little formula that I've left up here, where once we find all the parts to it, we can just plug everything in and figure out what we need. So with example 1, it says that a bank account contains $4,000 with an interest rate of 6% compounded semi-annually. How much will the account be worth in 5 years? So first, we have to figure out which of these numbers go to which part of the equation. So first, it says that a bank account contains $4,000. Let me get to a brush. Contains $4,000. So the initial starting amount will be the principal P. So that says that P is 4,000. And then it tells us that it's got an interest rate of 6%. So the annual rate is what we're talking about here. So R is equal to 0.06. Because it's 6%, remember we have to divide by 100 to get the actual decimal value for that. Next, it tells us that that 6% is compounded semi-annually, which means that it's compounded 2 times per year. This 2 times per year comes up in the M, the times per year variable. So M in this case is 2. And then it says how much will the account be worth in 5 years, where T is the time in years. So T is equal to 5. And since it wants to know how much the account will be worth, that means that A is what we're finding. So if we take that formula, we have A equals P is 4,000 times 1 plus R over M. So we have 0.06 over M, which is 2. And then to the power of M, 2 times T, 5. So now if we simplify this a little bit, we end up with A equals 4,000 times, that'll be 1 plus 0.03, so 1.03 to the 10th power. And then once you plug that into your calculator, we end up with, looks like $5,375.67. So this is the final answer for that one. So these examples are pretty straightforward. We pretty much just have to figure out which pieces go where, and then which piece we're solving for. So moving on to example 2, once again we're just going to figure out what chunks we need. So it says that Anne wants to have $6,000. So if she wants to have $6,000, that means that she wants her future amount to be $6,000. So A will be 6,000. Her bank offers an account that provides 8% interest compounded quarterly. So that 8%, remember, is the annual rate, R. So R equals 0.08, and it's compounded quarterly, which means 4 times per year. So in this case, M is 4. Next, if she has $5,200 to invest, meaning that her principal, or her initial amount, is $5,200, after how many years will she have enough to buy the car? So in this case, we're solving for T, since we don't know the number of years that the money's in the account. So if we take that formula and put all the numbers we know into it, we have 6,000 equals the principal, 5,200, times 1 plus, we have R over M, which will be 0.08 over 4, to the M times T power, which will be 4, and since we don't know T, we'll just leave that as T. So since we're solving for T, and it's in the exponent, we're going to have to do some log stuff later, but first we have to simplify it a bit so we can get to that point. So first, what I would do in this case is divide the 5,200 over, just to make it a little simpler. And if we do that, we end up with 1.15 1.385 on that side equals, if we simplify the stuff in the parentheses, it'll end up as 1.02 to the 4t. So now if we want to get this 4t down, we can take the natural log of both sides. So natural log of 1.15385 equals the natural log of 1.02 to the 4t. And remember, if there's an exponent inside of a log, we can bring it out front and just multiply it. So we have the natural log of 1.15385 equals 4t times the natural log of 1.02. So now we can just solve for t like we usually would by dividing by 4 times the natural log of 1.02. And then if we do that, we end up with t equals, let's see here in the calculator, 1.8065, which we can say is about 2 years. So in this case, 2 years, or the unrounded 1.8065, will be our answer for how many years it'll take to get $6,000. And that's about it. Thank you for watching.